Welcome to a review of testing aluminium melt, where precision and quality are of utmost importance. Testing aluminium melt for hydrogen. One of the simplest and oldest tests is the Straub-Pfeiffer test, or reduced pressure test. This test simply comprises taking a small spoon sample from the melt, pouring this carefully into a small stainless steel crucible of the size of an egg cup, and placing this under a bell jar from which the air is evacuated by a vacuum pump, reducing the air pressure to typically 1/10 or possibly as low as 1/30 of 1 atmosphere while the sample solidifies. The observation of the sample during this time is important. The emergence of many bubbles indicates the presence of gas. The reason for carrying out the test under reduced pressure is simply for the convenience of the magnification of the volume of gas by a factor of 10, or more if carried out at lower pressure. A factor of 30 is rarely exceeded. The pores are much more easily seen as they emerge at the surface and are easily visible when the sample is cut up for subsequent examination. Other tests for hydrogen content in the melt are based on sampling and measuring the volume of hydrogen gas that emerges under vacuum during the freezing of the sample. Clearly, this test relies on most of the hydrogen escaping and will thus probably give an underestimation of the hydrogen content of the metal where the metal is particularly clean. Other tests attempt to assess the gas content in situ in the melt and have the advantage of the possibility of continuous operation. Such devices include the telegas-type instruments originally invented by Ransley. These devices repeatedly cycle a small amount, about 3 milliliters, of an inert gas such as argon, or nitrogen, through the melt, where it picks up hydrogen. The hydrogen content of the carrier gas gradually increases, reaching a condition of equilibration between the hydrogen gas in solution in the melt and the partial pressure of hydrogen gas in the carrier gas. This takes about 5 minutes. The hydrogen in the carrier gas is measured. A recent variation of the Ransley test is the Campbell test, continuous hydrogen analysis by pressure evaluation in liquids. In this, a porous graphite probe connected to a pressure transducer is dipped into the melt and quickly evacuated. Hydrogen in the melt diffuses into the disk until the pressure in the probe and the hydrogen partial pressure in the melt have equalized. About 30 to 60 minutes is required to establish equilibrium, but this can be reduced by dosing the probe with hydrogen using the valve arrangement shown here. Since hydrogen is the only gas which dissolves in molten aluminium, the total pressure measured in the probe is equal to the hydrogen partial pressure. Testing aluminium melt for inclusions. A standard technique is the passing of a known volume of melt through a fine filter. The inclusions are caught on the filter and are subsequently identified and counted on a polished cross-section under the optical microscope. This sampling method is, of course, rather laborious. Two main types of continuous devices are currently used. They work on the following principles: ultrasonic reflection from particles and conductivity measurement. Thanks for watching. Remember to like, comment, and subscribe.